Hello everyone, this is the 6th chapter, correlation and regression. This is the last chapter of our syllabus. Okay, what is the correlation? Correlation means relation between two variables, suppose x and y, relation between x and y. Regression, correlation is the, see, in this chapter, we are going to see the relation between bivariate data, okay, relation between two variable x and y. If a particular type of relationship, for example, the extent of linear relationship is being measured using the correlation, such a measure is developed for quantitative and qualitative data. All of you know what is quantitative and qualitative data, variables and attributes, okay. Qualitative and quantitative means variables and attributes. So correlation is the relation between two variables, and the regressions are the lines. Okay, the relation between correlated variables can be established using the regression analysis, and it is useful for the forecasting, prediction of one variable. Suppose we know the value of x variable, then we can find the value of y variable because they are correlated. Okay, so we can find the value of unknown variables. If one is known, then we can find the other variable using the regressions. Okay, first we are going to see the correlation. What is the correlation? See, if rainfall and agricultural production, if I denote rainfall as a x and agriculture production as a y, they are interdependent. Okay, they are correlated with each other. Okay, if rainfall increases, agriculture production decreases. Okay, they are dependent, rainfall and agriculture production. Demand and price. Okay, demand increases, price also increases. Marks and intelligence quotient. Suppose marks is x and intelligence quotient is y. So income and expenditure. So they are correlated with each other. Okay, if one increases, other also increases. Something effect on others. Okay, by first element. Such interrelated variables are called as the correlated variables. Okay, means demand and price, they are correlated. Okay, that's why we call it as a correlated variable. And the extent of linear relations between these two variables, it's called as the correlation. Okay, now see what is the proper definition. Okay, we can say correlation, many situations come where the two variables are interrelated, okay, such as demand and price, income and expenditure, etc. Such an interrelated variable are called as the correlated variable. Okay, interrelated, interdependent variables are called as the correlated variable. And their linear relations is called as the correlation. In terms of x and y, linear means degree, having degree 1. Okay, in terms of x and y, the linear relation is called as the correlation. X and y means what? They are interrelated. Maybe x is demand, y is price. So they are interdependent, interrelated. So x and y, we called it as the variables. Okay, x, demand and price, x, suppose demand is x and price is y. So we called it as a correlated variables. X and y are the correlated variables, and their linear equation is called as the correlation. Okay, take a screenshot. Next topic is the types of correlation. Okay, positive correlation. For correlation I write like this. Okay, there are three types of correlation: positive correlation, negative correlation, and no correlation. So what is the positive correlation? Positive correlation means x and y highly correlated with each other. Okay, how it is? Suppose x increases, y also increases. X decreases, Y also decreases. Then we call it as a positive correlation. Okay. For example, marks and intelligence quotient of some student. Suppose a student have 60%. Okay. So intelligence quotient is first class. Maybe we call it as a first class. So it is also increases. Marks also increases. Suppose it is 45 marks. So X decreases, second class, second pass class. We call it as a pass class. So quotient also decreases, second variable also decreases. We call it as a positive correlation. Positive correlation means they are highly correlated. If X increases, Y also increases. X decreases, Y also decreases in the relation. So it is called as a positive correlation. See the proper definition. Positive correlation. What is the meaning of positive correlation? Definition asked in exam for 2 marks. In some cases, increase in value of one variable is associated with increase in value of other variable, or we can say decrease in value of one variable is associated with the decrease in value of other variable. So correlation between these variables is called as the positive correlation. One variable increases, other also increases. If one variable decreases, other also decreases, then we called it as a positive correlation. Okay, we called it as a positive correlation. Take screenshot. Next definition is negative correlation. Exactly opposite to the positive correlation. Okay. See, in some cases, increase in the value of one variable is associated with a decrease in the value of other variable. Okay, or we can say if first variable is decreased, then second variable increase. In this situation, we called it as a negative correlation. Suppose X increase, Y decrease. If X decrease, Y increase. In this situation, we called it as a negative correlation. Okay. Suppose supply and price commodity. Clearly, if supply of commodity is more, price fall down. Okay. Supply and price. If supply is increases, price fall down. So they are opposite in directions. So we called it as a negative correlation. One variable is increases, other variable is decreases. We called it as a negative correlation. Take a screenshot. And the next is no correlation. Simple. No correlation means this no suggests the meaning. What is the definition? Variables are not interrelated. X and Y variable, they are not interrelated. There is no relation between them. So we called it as a no correlation. For example, suppose height of first X is height of sun, and Y is, we can here student. Okay, height of student and marks of that student. Is there any relation? If height increases, marks also increases? No. If mark increases, height also increases? No, there is no relation. So we can say that X and Y are not interrelated. We call it as a no correlation. Okay. No relation between X and Y. Depending on the types of correlation, next topic is a scatter diagram. What is the meaning of scatter diagram? See, this is the perfect positive correlation. Why we call it as a perfect positive? Why we use perfect here? Because X, this is X axis, this is Y axis. So X variable here, Y variable also here, means X increases, Y also increases. Here X increases, Y also increases. Perfectly they are increasing. That's why we called it as a positive perfect correlation. Okay. Similarly here, See, if this is my x-axis, this is my y-axis, x is here, first x is here, okay, y is here. So x, this is x value, okay, so x is decreases and y is increases. So there is a negative perfect correlation. We called it as a negative perfect correlation. Next, positive, okay, positive correlation. Here x increases and y also increases. Somewhere they are scattered, that's why we are using here only positive correlation, but graph is increasing. Graph is increasing, x is also increasing, y is also increasing. Okay, similarly here negative correlation, x decreases and y increases. That's why we call it as a negative correlation. Okay. Next scatter diagram is no correlation, means we can't find the relation between x and y. What we predict from this diagram, first suppose x here, y here increases. Okay. What about this? What about this x? What about this? So we can't predict the relation between x and y. So this scatter diagram is called as the no correlation. Okay, we can't find the relation between somewhere x increases, somewhere y increases, somewhere x decreases, somewhere y increases. So we can't find the relation between this diagram. So we called it as a no correlations. This is the scatter diagram. Always ask in exam for 4 marks. Next is a covariance. Covariance is a tool for finding the relation between two variables. It is the next concept, covariance. See, covariance overcomes the drawback of scatter diagram, because scatter diagram does not give a numerical measure of correlation. Okay, it is a subjective method. It cannot be applied to the qualitative data. Okay. So covariance is the concept of statistics for finding the relation between two variables. Okay, it will be required to study the correlation and regression critically. The drawback of scatter diagram as measure of correlation can be overcome by covariance. Okay, the covariance is a joint mutual variation between two variables. Okay, nobody asked the theory parts. Okay, just learn the formula and apply for the finding the relation between two variables. So the covariance between x and y is denoted by like this, covariance of x and y, and it is defined as see, summation x minus x bar is the mean, y minus y bar, okay, divided by n. After some mathematical treatment, it gives the formula. Formula is summation xy upon n minus x bar y bar. So this is the important formula. Okay, nobody asks how it will come. Just remember the formula and apply into the example. Okay, just remember the formula. Okay, this is not a formula. Okay, this is the formula for covariance of xy. Okay, note first. Okay, these notes are very important because somewhere in exam they ask for true false. Covariance is similar to variance. Is similar to variance. Okay, covariance is similar to variance. Second, if I take covariance of xy, okay, is equal to covariance of yx. Okay, if I find the covariance of xy and then next covariance of yx, then they are equal. Third one, covariance of xx is the variance of x. Okay. Covariance of x and some constant is always equal to 0. Fifth, covariance may be negative, positive and 0, whereas variance is a non-negative, Okay, this is the note. Important note, may be asked in a true false or fill in the blanks. Take a screenshot. Next topic is Carl Pearson's coefficient of correlation. See, this is the next tool for finding the correlation between two variables. Nobody will ask the theory part. Just remember the formula and find out the solution. Okay. See, Carl Pearson coefficient of correlation is denoted by R, small r, and it is defined as summation xy minus n into x bar y bar divided by under root summation x square minus n x bar square into summation y square minus n y bar square under root. Okay, this is the Carl Pearson coefficient of correlation formula. It is denoted by small r, okay, or r equal to 1 upon n summation xy minus x bar y bar divided by sigma x or sigma y, depending on the theory part which formula we can use. Okay, we will see in the example. See, sigma x, we already know what is sigma x. Sigma x is the standard deviation of x and sigma y is the standard deviation of y. Okay. One more formula is there, r equal to covariance of xy upon sigma x and sigma y. If in the example, if they given covariance of xy, then we use this formula. If they given standard deviation, then we use this formula. If they given x and y values, x and y individual value, ungrouped data, then we use this formula. Okay, all three formulas are very important. Okay, depending on the theory part, we select the formula. Using example, we will clear where it is used. Okay, this one and this one. There are some properties for R. See, first property is properties of R. R means Carl Pearson coefficient of correlation. Okay, R lies between -1 and 1. Okay, if R is greater than 0, the correlation is positive. And if R is less than 0, correlation is negative between two variables. And if R is equal to 0, then we can say that they are uncorrelated. related. Okay. And suppose R equal to 1 means perfect positive correlation is, if R equal to -1, we can say that perfect negative correlation between two variables. Okay. Take screenshot of this note. It is very important. Always ask in exam in the first question for 1 marks, 2 marks. Okay. There are so many rules, so many theory parts, derivations, but these details are beyond the scope of this book or syllabus. So just remember this one and put it into the example. Third property is if the correlation, this symbol is for correlation, correlation x plus minus a and y plus minus b equal to correlation between x and y. Means if I increase the value of x, if I increase the value of y, if I decrease the value of x, if I decrease the value of y, then correlation doesn't affect. It is same as correlation xy. Okay. Fourth one, correlation between ax and by. It is also same correlation xy. Okay. If a and b have same sign, a and b have same sign. Okay. And if it is negative, then a and b have different in a sign. If a and b have different in sign, different in, we can say opposite in sign, opposite in sign. Okay, this is the fourth property. And the fifth one is correlation between xy is same as correlation between yx. Okay. These are the important properties. See in the Nirali book, this example already solved in the book. See what is the example. Following are the values of import of raw material and export of finished product. This is the export and this is the import. I denote export as a x, exported quantity as x, and imported quantity as a y here. Okay, this is the data given. Okay, calculate the coefficient of correlation between import value and export value. What we have to calculate? The correlation, coefficient of correlation. Okay, coefficient of correlation. We know coefficient of correlation is R. Okay, x and y value is given. So we find the correlation between them. Okay, I denote exported quantity as x and imported quantity as a y. What is the formula for correlation? Coefficient of correlation. R equal to summation xy minus n x bar y bar whole divided by under root summation x square minus n x bar square bracket complete into summation y square minus n y bar square bracket complete. This is my formula. According to the formula, I prepared the table here. Okay, what we required just prepared in the table. Okay, we required here x square, y square. Okay, we required xy, product of this two. So prepare the column x square, y square and xy. Okay, and their summation. Okay, x square means square of this observations. Okay, square of 10 is 100, square of 11 is 121, 196. Calculator is allowed. Put value in the calculator and find out. 400, 484, next 256, 144, next is 225, and next is 196. Similarly, find the square of imported values. 12, it is 144, it is 196, it is 225, 256, 441, 676, 441, 225, 256, and 196. Next column is xy. xy means product of these two. 10 into 12, 11 into 14, 14 into 15. Product of these two variables. So product is 120. Here 154. Okay. This is the product. Okay. Now we required total. Total of here 147, 170. 2291, here 3056, here 2638. Okay, this is the total. Now, in the formula we required x bar and y bar. As we already know, what is x bar? X bar is the summation x upon n. Okay, sum of all observation upon number of observation. Y bar is sum of y upon small n. We already studied this. Okay. So sum of x is 147. 147 upon n. N is the number of observation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10. Y bar is equals to total of y is 170 divided by 10. I write here x bar is 14.7 and y bar is 170 upon 10. So it is 70. Okay. Put all values in the formula and find out r equal to, see, summation xy is this 2638 minus n. N is a 10. Okay. X bar is 14.7. Y bar is 17. Whole divided by under root. Just put all values. Summation x square is this 2291 minus 10 into 14.7 square. Okay, into, I write here 3056 minus 10 into 17 square. See, put all values in the calc and find out. So it is 0.9458. Okay. This is only subtraction, addition, subtraction, multiplication and division. Okay. Do it properly and find out the answer. R equal to 0.9. So there, what is the interpretation? R equal to 0.9. There is a high positive correlation. Okay. So 0.9 tends to 1. Na? So this is the highly positive correlation. We can say high positive correlation between export value, between x and y, export value and import value. Okay, this is the solution of the example. Take a screenshot. If any doubt, ask in comment. Okay. Share to your friends. Share and subscribe. Thank you.